Welcome viewers. In this video we will see the solved problem for reduction of switching equation by Boolean algebra simplification method. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the problem. We need to reduce this switching equation by for the using Boolean algebra. In this method is a simplification method. The given expression is AB plus AC bar plus AB bar C into AB plus C. So this is the given expression. We need to simplify this. First we will multiply these two terms, this term inside this term. So that what we have, AB first term, AC bar second term. Now we will multiply this, AB bar C into AB, right? So that B bar C is available. A, B bar, B into C. Then multiply these two terms. A, B bar, C into C. A, B bar, C into C. Right. So, B bar is 0. We know that B into B bar is 0. Similarly, C into C bar is C. Any term multiplied with the same term in, we will get the return same term only. So, this term become 0. This term become A, B bar, C. Right. Now, we have the AB plus AC bar plus AB bar C, right? It is nothing but AC bar. This AC bar, by using the De Morgan's theorem, this AC bar can be written as AB whole bar equal to A bar plus B bar. Similarly, AC bar equal to A bar plus C bar, right? So now what are the terms we have? AB plus A bar plus C bar plus AB B bar C. Now we can use this theorem, A plus A bar B equal to A plus B. What is that? A is written as it is, B is written as it is. A complement is A bar, that no need to write. So based on that we can write this, AB plus A bar is nothing but A bar plus B, right? This is the first term, single term written as it is. In double term, complement is not written, remaining term is written. So this single term is written as it is. The complement of A bar is A, no need to write, remaining term is B, right? So that this AB plus A bar is written as A bar plus B, and C bar is available plus A B bar C. This A bar plus A B bar C is written as A bar plus B bar C. Same thing. Single term is written as it is. Complement of A bar is A, no need to write. Remaining term written as it is, right? So that A bar, this A plus A, first and last term. First and last term is written as A bar plus A B bar C, right? The next what we have, A plus A bar equal to A plus B. Again we are applying the same theorem. So it is rearranged. A bar plus B bar C plus B plus C bar, right? Now we'll rewrite that. This A plus B bar C plus B C bar. This B bar C plus B. This can be written as B plus C bar, right? So the A bar is as it is, B bar C is written as it is, right? Only so this B and B bar, this term is rearranged, A bar plus B C bar plus B bar C. Now it is rearranged, not simplified, it is rearranged. Now we can go for the simplification. This C bar plus B bar C can be written as C bar plus B bar, right? This term is now simplified as C bar plus that is single term is written as it is, and that double term, the C bar complement is C, no need to write, remaining term written as it is. Now what we have, A bar plus C bar plus B plus B bar. So this B plus B bar is nothing but 1, B plus B bar is 1. So that we have A bar plus C bar plus 1. But we have one more expression, A plus 1 equal to 1, right? If any variable added with 1 will give 1 only, right? Because A may be either 0 or 1, whatever may be, while added with the 0 will give only 0, answer will be 1, right? So based on that, A bar plus C bar plus 1 equal to 1 only. So the answer is here we have 1, right? So the expression is simplified step by step. We use the De Morgan's theorem and also we use this property. Finally we got the answer as 1. Now we'll go to the second problem. The second problem is given a bar b plus a bar b c bar plus a b c d plus a b c bar d e bar d e, right? So this expression is given. We need to try to take the common terms outside so that we can go for further simplification. We need to identify which term is common. So a bar b is available commonly, right? Here also a bar b is available, here also a bar b is available, right? So we'll take this a bar b outside, right? So this is a bar only, this is also a bar, this is also a bar, right? So in all 4 terms a bar b is available, right? So if you take a bar b outside, it is 1. If you take a bar b outside, remaining term is c bar. If you take a bar b outside, remaining term is cd. If you take a bar b outside, remaining term is c d bar into e, right? So what we have, 1 plus c bar plus cd plus cd bar e, right? What is a plus 1? Whatever may be the expression, plus 1 means the final value will be 1. So 1 plus these terms, whatever may be, this value may be anything, it may be 0 or 1. If it is 1 plus 0, it will give 1 only. If it is 1 plus 1, that also give 1 only, right? So we are using this property a plus 1 equal to 1. Based on that, this value will be 1. So only what we have, a bar b, right? So this expression is simplified as a bar b. By taking a bar b outside, we have the term 1 is there. So 1 plus any term will be 1 only. So finally we got a bar b. So in this problem we discussed the reduction of switching equation using Boolean algebra simplification method. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.